Even people in calculus have a tendency to make sign mistakes in their math. So let's make sure that everybody thoroughly understands what the rules on doing operations, that's adding, subtracting, multiplying, and dividing, are based on the signs of the numbers. Anytime you're going to add numbers that have the same sign, both numbers are pulling you in the same direction. If you look at it in terms of on a number line, and excuse my not so straight line, if you want to add a +2 and a +3, that is still 5 exactly as it was back in kindergarten. But we need to start with things that are where we already know what the answers are, so we can figure out what the rules are so that we can extend those same rules to numbers where we don't automatically know what the answers are. A +2, if we start at 0, would carry us 2 units in the positive direction, which is to the right. A +3 would carry us 3 more units to the right, so that if we take a +2 units and a +3 units, 2 units to the right and 3 units to the right, we end up at the number 5. Now, likewise, if we take a -2 and add a -3, the -2 is going to move us. Let's change colors. The -2 is going to move us 2 units to the left, 1, 2. The -3 will move us 3 more units to the left, 1, 2, 3. So because both of these are pulling us in the same direction, we've now gone 2 units left and 3 more units left, which is a total of 5 units to the left. Anytime you add 2 numbers that have the same sign, the absolute value refers to the number part. So the absolute value of 2 is 2, and the absolute value of -2 is 2. So the absolute value is just the number part. So you add the number parts and you keep that sign. If we want to add a -5 and a -12 and a -50, that's going to pull us a total of 5 plus 12 plus 50 units in the negative direction to the left. So we're going to end up at a -5 plus 12 plus 50 units to the left, which is going to be 62, 67. We'll have gone a total of 67 units to the left. So just like a +5 and a +12 and a +50 would move us 67 units to the right, then a -12 and a -5 and a -50 will move us 67 units in the same direction as each of these numbers, which is going to be to the left. Now, to add numbers that have different signs, because one of them will be pulling us to the left and one will be pulling to the right, they're going to pull in different directions. So one will move you this way and the other one will move you back the other way. Or perhaps you might go to the left first and then go back to the right. If you keep constantly going back and forth, you're not getting farther and farther from 0. There's a good chance you're actually crossing back over 0 at some point. How does it look on a number line? Well, we always start at 0. What if we took a +5 and we added a -3? The +5 is going to move us 5 units to the right. But then the -3 is going to carry us back 3 units to the left. So now we go back 1, 2, 3 units. And we find ourselves directly above the +2. Okay, that makes sense. We moved more units to the right than we did back to the left. So we're still to the right of 0. So 5 plus a -3 is a +2. Addition is commutative. So a -3 done first and then a +5 should still result in a +2. Does it? Well, let's find out. I erased my rule there. If we start out with the -3, 1, 2, 3 units to the left. And then we go 5 units in the positive direction, so 5 units to the right. The first 3 units of the 5 is taken up in getting us back to 0. And then we still have 2 more units to go to the right. So a total of +5 units does indeed place us directly above the +2. Notice that 5 minus 3 is 2, just like it was back in kindergarten. 5 minus 3, subtracting the +3, is exactly the same thing as adding the -3. Subtracting means go the other direction. So if you go 5 units to the right and then you go the other direction to the left, has to be left because that's the only other direction we have. So 5 to the right and then 3 to the left is exactly the same whether you're saying you're subtracting the +3 or adding the -3. So subtracting a regular number is the same thing as adding the negative number. We'll talk in a minute about what happens when you subtract a negative number. Now, what if we'd had a +3 added to a -5? What if we went 3 units to the right and then 5 units to the left? Okay, 1, 2, 3 to the right, and then 5 to the left. Now the first 3 out of those 5 take us back to 0. 2 more, 1, 2, drops us on top of the -2. 3 to the right and then 5 to the left is going to be more movement to the left than it is to the right. So we're going to end up on the negative side of 0. Likewise, a -5 added to a +3. If we start out going 5 units to the left first, so all the way over to -5, and then 3 units back to the right, that doesn't make it to 0. We've gone farther to the left than we came back to the right. So we're still over the -2. And again, this could be written as 3 minus 5. If you have a positive number and then you subtract more than you actually had, a +3 minus 5 would be 3 to the right, 5 back to the left. We've gone past the 0, on over to the -2. So notice that once again, 3 minus positive 5, we could write this as 3 minus positive 5, but we don't need to. 3 minus 5 is the same thing as 3 minus a positive 5. It's the same thing as 3 plus a negative 5. Minus a positive is exactly the same thing as plus a negative, which is the same thing as just subtracting under normal circumstances. Although in first grade, you weren't allowed to do 3 minus 5. They just said, oh, I'm sorry, you can't subtract 5 from 3. There's not enough. So the rule is to add numbers with different signs. What we've done here to add a negative 5 and a positive 3 is actually take 5 minus 3, but then we kept it as a negative. Here, we did 5 minus 3, and because the 5 was larger than 3 and the 5 was positive, the answer was positive. Here, with a positive 3 and a negative 5, because 5 is still larger than 3, in a contest between a 3 and a 5, the 5's always going to win because it's bigger. So this answer is going to be a negative 5 minus 3 is 2. This answer is going to be a positive 5 minus 3 is 2. So to add numbers with different signs, get the difference of the numbers and keep the sign, instead of saying from the one with the largest absolute value, can I just call that the larger? Although technically any positive number is bigger than any negative number, but we're talking about the number part. If you have a bunch of numbers to add together, let's say you want to take a negative 3 and a negative 2 and a positive 7 and add a negative 8 to that and add, I don't know, 12 to that and negative 3 to that. Instead of constantly changing the direction and deciding whether to add these or subtract these and whether it's not, the easiest thing by far to do is to get your positive sum. Add up all your positive numbers. That would be the 7 and the 12. And that is, of course, going to be a positive number. When you add positive numbers, you get a positive number. So 7 and 12 is 19. Get your negative sum. Add up all the negative numbers, and the answer is going to be the negative of whatever the sum of the number parts is. So this is going to be a negative of 3, 2, 8, and 3. So a negative 3, a negative 2, a negative 8, and a negative 3 is the same thing as the negative of 3, 2, 8, and 3, which is going to be a negative 16. And then add the sums. So we're going to be adding, except for the very last step. If we add a positive 19 and a negative 16, which you'll notice is going to be the same thing as 19 minus 16. The 19 is larger, so it's going to win. So this is going to be a positive answer. And the difference between 19 and 16, because these have different signs, is going to be a 3. It is far easier when you've got a string of numbers with different signs to add up, is to add up all your positives, and that's your positive sum. Add up all the negatives, that's your negative sum. And then you only subtract one time, and whichever sum was larger, the positive or the negative, had the larger number part, determines the sign on the answer when you subtract the two number parts. When you multiply or divide signed numbers, It's actually way easier than adding and subtracting them, because when you add or subtract, you have to look at the numbers signs to determine whether you're going to add or subtract the number parts, and then look at the number parts to decide whether the answer is going to be positive or negative. With multiplying and dividing, the sign is totally determined by the signs. The number part is totally determined by the numbers. So these are completely separate steps. Just like in third grade, 2 positives adds up to a positive. Before you knew there was anything other than positives, you never had any trouble with the signs. So +2 times a +3 is a +6. A positive number times a negative number is negative. If +2 times a +3 is a +6, then +2 times a -3, and we always put parentheses around a number if there are 2 operation signs there, just to separate out the signs. +2 times a -3 is a -6. If you look at 2 times 3 is 6, 1 times 3 is 3, 0 times 3 is 0, -1 times 3. These are dropping by 3 each time. So to drop 3 more, this becomes a -3. -2 times 3 is -6, still dropping. So either a -2 times a +3 or a +2 times a -3, both are going to result in a -6. So we see that a negative times a positive will also be a negative. Multiplication is commutative, so it doesn't matter which order you're multiplying the numbers in. What about a negative times a negative? Well, so far we've got 1 positive and 2 negatives. So it kind of evens it out if this is a positive, but it doesn't seem to make nearly as much sense intuitively. If we know from here that -2 times a +3 is a -6, and -2 times a +2 would therefore be a -4, right? Positive times a negative. -2 times 1 has to be -2. Anything times 1 is itself. -2 times 0 is going to be 0, because anything multiplied by 0 is 0. So what about -2 times a -1? Well, here, -6 plus 2 is -4. If we're at -6, we have to move 2 to the right to get to -4. 2 more to the right will move us to -2. 2 more to the right will move us to a 0. 2 more to the right would be a +2. A -2 times a +1 can't be the same thing as a -2 times a -1. So if -2 times 1 has to be -2, because anything times 1 is itself, and -2 times a -1 therefore cannot be -2, it makes sense that it's a +2. So a negative times a negative is a positive. So the short version is this: when you're multiplying or dividing, if they have the same sign, it's positive. If they have different signs, it's negative. And again, these are different rules than what you get when you add and subtract numbers. If you've got a whole string of numbers that you're going to multiply, -3 times 2 times -4 times -1 times a +5. What you want to do is count your negatives. Don't try to multiply 2 of these together, keep track of the sign, times the next one, keep track of the sign, no. Just count your negatives to start with. We have 1, 2, 3 negatives. If you have an even number of negatives, the answer is going to be positive. That's because if there's an even number of them, you can pair them up, and every 2 negatives gives you a positive. If there is an odd number of negatives, so that when you pair them up, there's going to be 1 left over, the answer is negative. So with 1, 2, 3 of these, that's an odd number. The answer is going to be a negative. And then you just do 3 times 2 times 4 times 1 times 5. So it's going to be a negative 20 times 6 is 120. That's all there is to it. Multiplying and dividing is way safer. And the rules are exactly the same whether you're multiplying or dividing. So that one is really straightforward. I hope this helped. They're not that bad. You just have to keep track of them. I would make determining what the sign is to any answer a separate step from the rest. Don't try to keep track of your signs and your numbers at the same time. Take a look at everything, figure out whether the answer is going to be positive or negative, and then do the arithmetic part. That way, if you've set figuring out what the sign is as a separate step to itself, you're much more likely to get it right and not get all tangled up in stuff. Hope this helped. Talk to you later. Bye.